Hey guys, welcome back. In this particular video, we're going to be taking a look at IPv6 ACLs. We'll take a look at some of the similarities between IPv4 ACLs and IPv6 ACLs and the differences between the two. All right, so let's get started with that. The main objective, main topics that will be discussed in this particular video, IPv6 ACLs, an overview of them, how to configure them, the commands for it, and how do you apply it, and a couple of examples for that. All right, so just to take a look at the overview of it, what are the things that are similar and different between IPv4 and IPv6 ACLs? Again, just like IPv4 ACLs, it is again a way of identifying network traffic. Once you have identified the network traffic using IPv6 ACLs, I can use it in different technologies like traffic filtering, one of the more common usages of ACLs over here. We can also use it for quality of service, which we'll discuss later on in this course. We can use it for VPNs as well. Again, just like in IPv4 ACL, it consists of multiple access control entries, which are the actual permits and deny statements inside an IPv6 ACL as well. Just like IPv4 ACLs, it uses the top-down first match type of mechanism where the more specific things are at the top. Once a match has taken place within an IPv6 ACL, is going to take action based on that match and exit the ACL, just like on an IPv4 ACL. And also, just like an IPv4 ACL, it also has that deny all statement at the end of every ACL. So if you have a deny statement in an ACL, you should always have a permit statement, because if you just have a deny statement, it's not only going to deny that, it's going to fall into the implicit deny any and block everything else. The only difference is you don't say IPv4 AC any, I say IPv6 any. Subtle difference over here. Other than that, it's pretty much the same. Now, the next thing is the differences. What are the differences between IPv4 and IPv6 ACLs? One major difference, when you create an IPv6 ACL, it can only be a named ACL. It cannot be a numbered ACL, so no numbered, and it's an extended ACL. So automatically, without you specifying it, it knows that the ACL that you have in IPv6 is a named extended ACL. What does that mean? It has the ability to block based on source destination address and the protocol. It does not have the ability to just block based on the source address. The other difference, when you apply the ACL, when we're applying an IPv4 ACL, we were using the IP access group command, followed by the name or number and the direction. In IPv6, the command changes first of all to IPv6. It doesn't use an access group command. Instead, it uses the command called traffic filter under the interface, and it's always going to be a name, inbound or outbound, just like on an IPv4 ACL. That's what this is all about, in and out. All that is the same. Now, what I've done over here is I have set up your network already based on this diagram that we'll do the examples based on. So if you take a look at over here, in this network, I have the FC001:1:1/64 on the Ethernet segment. The IP address of the PC is FC00:1:1:1:50. This guy is FC00:2:2:2:50, and this guy is FC00:3:3:3:50. These guys are :3, :2, and :1 as IP addresses, and they would be the default gateway for them. So to test it, let's see if I can ping from this guy to the 3 network, the 2 network. To make it simple, I'll just ping the router interfaces. Let's go over there, open my command prompt up. I've configured the IPs on it already. I can show you how to check that. When you do IP config, it'll tell me that I have configured. Over here, take a look at it. Shows me that my IPv6 address is The default gateway is 1:1:1, and my actual address, IPv6 address, is FC00:1:1:50. Similarly, we have, and I can ping the 3 network. So let's try to ping it. Ping FC00:3:3:3:3. So my ping is successfully happening between the 1 network and the 3 network. Similarly, I'll bring up my other device, which is this guy over here. Same concept. I'll open this up. ipconfig. This is the 2 network. 250 is the IP address. 2:2:2:2:2 is my default gateway. Let's ping 1. Working. Let's ping 3. Also working. And the last device over here would be this guy, the 3rd device. And let's set that up over here as well. Three colon 50, and 3:50 is my 3:3 is my default gateway. So another 1:1 pingable, and also 2 pingable. So all my network, this particular network, is fully routable, reachable. My first ACL over here blocked the host FC00:50. That is the host behind R2, this guy over here. I want to block that from accessing the entire 3 network. So deny IPv6, that means any protocol, source of FC00:2:2:2:50 should not be able to go to any device on this particular network. Permit the rest of the traffic. Apply it to the interface by using the traffic filter command over here. ACL1 is the name. You don't specify any number for it. So let's go ahead and take a look at this real quick over here. So we saw that it was working prior to the ACL. So let's go to router 2 and create the ACL. And when I create the ACL over here, IPv6 access-list. I don't need to specify standard extender or anything like that, just a name. All right. So I'll say the name is ACL1. It puts me into the subconfig mode. This is where I'm going to deny any IPv6 traffic from this host, which is 2:2:2:50 to the 3 network. So 3 network I can specify with /64, and I want to permit the rest. So permit IPv6 any. Once I create it, I need to apply it to the interface closer to the client, and that's what I'm doing over here. IPv6. My power is running out, so I'll just need to put this in. IPv6 traffic filter ACL1 inbound. Now that I've done that, to test it from 2 to the 3 network, what I'm going to do is I'm going to go to my PC over here. I'm going to do ping FC, the same ping for the 3 network, but this time around specify the source for the host. So I need to make sure it doesn't use a linked local address. It uses my real address, which is 50. So right now it says destination network unreachable, or you could do 50, or this is not reachable. Okay, if I tried the one network is okay because I blocked this guy, the 2:2:50 address reaching the 3 network. 1 is absolutely okay. That's why it's working. So that took care of the first ACL example, where I allowed you the ability to filter traffic based on what? A particular host going to a particular network. All right, and this is how you apply it. In the second example over here, what I'm going to be taking a look at is not just the IP, but also the protocol. Again, same network. I am not changing it. I'm just building on top of it. Now, in this particular lab, I'm going to be taking a look at to block the one network from accessing the 2 or 3 network, but specifically only for ICMP, and that is echo request. Permit the rest of the traffic, configure R1 to do the block. So I want 1 to be blocked from pinging the 2 and the 3 network using an ACL. So how do I go about doing it? Because it's specific to the protocol. What I'm going to do over here is I'm going to go to router 1, create this IPv6 ACL, I'll just call it ACL1, deny ICMP. The network is FC001:1:1:1:/64, the entire network. Block it from going to the 2 network, the entire network. All right? But for what? For echo request. Yep. There you go. And I'm going to deny it for the 3 network as well. /64. And then permit the rest. Show IPv6, access-list, deny 1 to the, 2 network and the 3 network, permit the rest. All right, once it's done, I'll apply it to my interface, IPv6, traffic filter, ACL1, in. So I've done that. Now let's go ahead and test it. I'm going to go to PC1, which was successfully pinging the 3 network. Now what I'm going to do over here is I am going to see if this works. It should not work anymore. Why should it not work? Because of the block. Or for that matter, the 2 network, unreachable. All right. If I try to ping, let's say 192.168, :23::3, which is router 3, that is pingable. So I only blocked the 1 network from pinging the 2 or the 3 network. Similarly, you can do it for Telnet. You can do it for HTTP. The different protocols are also available to you guys over here. So this is an IPv6 ACL. So you can see subtle differences like the prefix list over here. Oh, by the way, I didn't mention that. In an IPv6 ACL, I don't have the inverse mask. Instead, I have the prefix mask, which basically means when you put a /64, matching bits are the first 64 bits, which is basically my network. If you remember, in an IPv6 address, by default, the first 64 bits are what? The network bits. So when I say /64, it means just match the first 64 bits. The last 64 bits are your host bits. And those are the ones that I don't really care about. And that is an IPv6 ACL. And that concludes this section for ACLs. The next thing we're going to be taking a look at over here is the switching section. Very important section. The second most important section in the class, right after routing. So hope to see you guys over there. Thanks for watching.